Hello, welcome to the next video. Before we continue creating the interiors and the walls, there's a little error I captured in the previous video. It's where we were creating the panels, and when we create the panels we are using a cluster points to cluster each panel, right? But here there was an attribute mismatch, so now basically I was trying to get the output of one of these panels that is coming from here. Let's say I want to add additional detail to one of these, right? So I start doing one by one, actually, by turning off by turning on the single pass. So I captured one. Previously it was removing everything inside, but originally what I wanted was to get uneven boxes. So this is the part now I'll try to utilize. What happens is if I turn this off, cluster point is going to work on everything, and then you will need a really big cluster number to get the same level of detail. So we'll probably have to, oh no, actually, because it's working in the loop, right? Yes. Okay, so these are looking much more tech-like panels, as opposed to, I think before it was temp clusters, it was using a different attribute, which it's fixed now. Anyway, so if you compare to what it was as opposed to now, this is feeling much more like a technology type of paneling. These ones are pretty much useless, but so and if we do a little primitive to pull back everything else, so you get a little these broke up edges that are much nicer. So the part that you can play here in this section is to decide how big you want your threshold group to be. So we can do something like this, group by area. We put a slider here instead. CHF is, you know, referencing for a slider, float slider, and then we call it threshold. Usually I always name them threshold. Double parentheses to close it, and if you hit this guy, you'll get a slider. And if you visualize this and start sliding this, so it starts from 100, right? You'll start losing the smaller pieces, whereas keeping the bigger faces, because we're using the area to split these guys. So we are using originally 100. So this is like the result. So these are the smaller pieces, actually. So because we say if area is bigger than 100, remove, no, set group and split it by big. So this should be the big pieces. This should be the not so big pieces, which is 0. Okay, so if I look here, they kind of look similar, but then it's being, some of these small ones are isolated. As you guys can see, these edges are a lot smaller than what you have visible here. Maybe a few. They could be very well in the threshold, but the goal is to not everything look like with high-tech panels, so just to create some variety. Okay, so this seems to be fine, and now again I am gonna merge these with the big ones, because I think I'm putting the small ones here. Yes, the small ones are coming here to be processed in these loops. So then if you merge these with these, then we'll get the output. I think we put a normal, the colors will get fixed as well. Yes, we can always put the normal way at the end, but it's not that important here. Okay, now let's continue creating our windows. Maybe we can do a little merge here as well to see where we are at as a whole. So this one and this one. So we still have to make the frames, we still have to make the walls, but our our building is coming together. It looks very sci-fi-ish. Okay, so let's start by window frames. Again, we're gonna run it in a loop. And I'm going to get the floors in here first. So let's object merge. The remove, okay, this one was called, okay, let's rename this one, remove small areas. If there's any isolated small floor left out, this is why we are doing this, because there's a bunch of random shapes, and if you end up with a really small one, you don't really want to make it a floating island. Like, you know, there could be something right here, and if you don't isolate them, they're still going to be treated as a room, right, or floor. So this is basically why we're doing this. So what I want to do here is that I don't want to create a floor for each one of them, create a little variety. So let's put a delete sub and remove some of those. In delete by range, and basically I'm saying remove 30%. It kind of gives me these gaps. Maybe these are where the flying cars going, or you can do like this, you know, or you can hand select them based on a shifting object randomly, which is not a bad idea, I guess. We can shift the start end based on we cannot go up more than certain distance, so let's leave it for now for 0, and let's go, this one was 3. Bear in mind, this is a really high building, it's almost 400 meters. All right, now let's do a for each again. It's all about for each primitive, because each floor is at the moment a primitive, right? So you can isolate it simply by using for each. We don't need names or anything. So what I'm doing is, because we're going to do extrusions and stuff, I have to do a little cleanup. Start with divide, turn off convex polygons, and turn on remove shared edges. So this is going to, it looks ugly, but we're going to do more cleanup to it. Then you put ends, because I want to get rid of the because I already have floors here. This is for just to capture the edges. And ends unroll with shared points. So if I look here now, I just have curves. Okay. Now, based on how thick we want these floors to be, they're not totally random. I'm offsetting a certain degree so they don't overlap. These actually I created after I have, you know, generated the entire floors and see, oh, okay, there's a little overlap, and if I offset it this much, it should work, and it does, because remember, we are not varying our floor height. So if I did, I would have to connect the transform value to somehow to floor height, but since that's like every floor is, let's say, construction code, so this value at the moment works fine. Now I'm going to create extrusion vector. I'm basically going to feed that into poly extrude. So because we can feed values directly into the extrusion to tell them which direction you want the polygon to be extruded. Basically now I'm saying creating a vector, says extrude direction, and I'm feeding in a value. I'm saying always extrude towards -1 in height. Now let's put a poly extrude. Okay, and change extrusion mode to point normal, to attribute, and let's type here extrude there, and the amount is 4.35, again related and connected to the height of our never changing floors. Basically, if you make that automatic, let's say if you make that randomized between I don't know, 50% less or 50% more, you need to compensate these values. Floor edge height. All right, now what I want to do is I'm going to actually bake this on my other scene, but we do want to let me see, because we really don't need the output front. So what happens is that all these nodes start creating overhead. So I actually started turning off things to speed things up. You wouldn't probably normally notice it until, you know, it's too late. Let's say delivering something and everything takes too long, and then you don't want to change anything because you don't know if it's going to break. So it's safe to it's a better practice to do this. And there's a little section that I'm going to show as well, which is called performance monitor. I use this all the time, and it's really a nice way to say, oh, this is taking too long, can I replace this node with something else? But we haven't finished it yet, so we're not going to use it now. So let's while this is cooking on my other screen, let's put blast. Let me see in this one, yes. So what I'm doing here, oops, sorry, delete. I think I should show this to you in wireframe to see the extrusions a bit better. Okay, so first thing is that we had the top of the floor, the ceiling, then I'm extruding it down, right? The full amount of the floor, it should overlap with these floors. There's a little gap, we're gonna offset that as well. But it's pretty close. Let me check with my other scene, but I think that's exactly how it is now. Well, maybe this is too much. Oh, actually, I think this is better. Even so, there's a little offset. We'll get back to that one to make sure that it's correct. Where are we? Maybe it's from this transform we had before. Okay, we'll have to be careful with that one. So let's put another. This part was the difficult part for me as well, to make sure that this overlapping was not breaking anything, or not overlapping, because there's a lot of factors that you need to adjust. So extrusions are all done right. Let's call this one edges. So I'm kind of gonna extrude this with the inset now, 0.25, so I can capture the this upper area and lower area. So this is my glass area basically. So this, from more glass, less glass. Make sure you're outputting extrude front, and that's pretty much it. Now we're gonna do a blast to capture both ends. So this one is not extrude front, so that's the glass. So you can call it, is it the glass? I think it's the glass, yes. Glass area at least. It's gonna be processed anyway. Let's call this keep glass. obviously we need the opposite. I'll call this keep frame. Well, this is not the frame, this is kind of like the support, I guess. Keep wall, outer wall. Okay, now a little poly wire to get the frame from floor edge height. Okay, so kind of getting this section now. Default values is fine, so this is like 10 centimeters. There shouldn't be any weird attributes so far. So what I'm doing is now kind of creating IDs again. So attribute create, and I'll call this ID frame glass, but this is just the name of the node. The material, the name of the material, the name of the attribute is material. It's a primitive. Set it to string and name it ID frame. Okay, we can do the same thing on this left side. So we kept this part, right, but it's still a flat object. So let's make it thicker now. Another poly extrude. Point 3, 0.2, as you wish. Output everything. All these. This is just says you want to output these faces basically, unless you want to do something else. That gives us thickness. Now let's duplicate this. This one is also ID frame, or you can give it a different name. But yeah, so you can just you can just use this one. Still a frame. This is also a frame. Maybe this could be frame 2, frame 1, or you can actually give it attributes. But I prefer to just collect this. Like once I finish everything, let me show it this way to you. Once we finish all of this, we'll object merge all of this here based on their outputs. We keep the attributes anyway, and then we're kind of gonna recreate the groups and everything. It's just a cleanup process and merge all into a working asset. But it's it's a lot of the design goes through a lot of changes. And usually never do optimization towards, or if there's enough time at the end maybe, but so far this is clean enough, and we'll keep it as it is. Let's do the glass. So the glass needs to be ID glass, obviously. ID glass, so we know it's glass. Let's do a little poly extrude so the glass has thickness as well. Obviously not that thick. So it's kind of like reverse, but we're gonna fix that after. We can do it inward as well. What happens if we do it positive? Yeah, that should work. Let's keep it that way. So then what I'm doing is I'm creating a little group called glass, because I'm gonna fracture the glass completely different. Okay, and there's a little overlap happening here to here because of all the extrusions and polyframes. So we're gonna do a boolean. It's solid to solid and it's union. Okay, because these are both. So it kind of like, you see what it did? It was like this. Actually, let me put a merge. So it was kind of like this, and Boolean did a nice cleanup. To be fair, Bullet can handle this much intersection, but things will go faster if you supply more clean meshes, initial intersection solving, etc. And when you're simulating million pieces with so many other wedges, you want to squeeze out every single FPS from simulation, right? Let's call this now window units. Window units, and let's complete the wedge and see what happens. Actually, there's a little. We can fix that after. No, let's fix it now. Again, because it finds normal on one, it doesn't find the normal on the other one, so it makes it black. These frames can be soft, rounded. Yes. Again, if you want more detail, you'll have to go to polywire and increase divisions to 8, let's say, and you'll have more rounded shapes. It's by preference, to be fair. There's a part here that doesn't look right to me, and I'd like to fix it. It's actually the same in my previous scene as well, but it goes, no, let's keep it. If we don't like it, we can change it later. Okay, let's save and let it cook. Maybe call this part 4. I think these are gonna go quite a few parts. Okay, now let this cook. I think this is the one that takes a little while. And this is also the one that usually creates really stretched geo, that is because of the extrusion. And sometimes that's why I think this is also why I was feeding in vectors that are handwritten. Okay, so we have now our office space from outside. Now let's put a blast, isolate the glass. We did not create the group. I think we did, or we didn't. Oh, yes, my bad. Glass. And now let's wait for it to cook again. Okay, almost done. Now blast. Now glass should be there. Isolate. So we got our glass only. I guess we have a lot of attributes now we really don't need, so we can do a little cleanup. I really don't need any point attribute at this point. I also don't need, I think, any of these except maybe the floor integer, which is 0 anyway. It's broken here. Okay. Yeah, no, we don't really need anything but the material. A little cleanup, and I actually don't need even the groups. No, let's do this. Delete unused groups. So there's a glass, there's extrude phone. Actually, I also don't need any of the basically I don't need any group by glass here, right? So maybe group delete. Again, I think I did these at the end, so we can just do that too. To be fair, all we need at the moment is this, so we can, once the output from here, we can do another cleanup later. The normals look healthy, so let's put a null. Call it out windows. Out windows. Okay, now we need the opposite. Our frames, right? It looks like our normals are healthy as well, so I'm not gonna touch that for now. because no, actually, let's do that. I want to keep glass only. So basically glass, and then you can say everything but glass. So you'll have the glass. And here we can say everything but it's already just window groups. And then we can say out frames. Okay, so these are our windows 11. And now let's remember we left a gap. Oops. Those gaps. Let's do something with those gaps, which is the opposite of this, right? So basically, you can just copy this and say delete non-selected. Then it's going to give you the opposite. Then we can do something like this again. We can, for each loop, again primitives. Process them one at a time. Something pro. Oh, not by name. For each primitive. For the name, for name to work, you need to supply a name attribute. So there's 25 floors, empty. So let's go like this. Again, a little cleanup in case. Excuse me. In case we have islands. So divide. Remove convex polygons, remove shared edges to make sure we have the we have removed anything, any crisscrossing polygon inside. We're gonna, because we need to extract the outer layer. So I think it's still the same settings. Unroll the shape points. Yes, and extrude there. So I'm just gonna actually copy this guy. Okay, and I'm doing a poly extrude. And this time I used an expression. Basically, I am using point normal, and the distance is calculated from the floor gap value, the 99th percentile of the floor gap value, which is coming from here and here, this guy. So because you can't copy paste this, you need to use the detail attribute to extract it. So then it goes detail, you know, you put your double quote dot slash, you find your node you need to extract information from, and you say I want to read floor gap. Oh, sorry, it's a string. Floor gap. I want to read the first attribute of that because it's a float anyway. So this should give you 5, but we want to squeeze it down just a nudge. Okay, so it's that. I'm just gonna change the color on my other scene because I cannot see my connections. Okay, this is not connecting it to anything. All right, so then I'm going to give it a thickness. Right, I can create another extrude, poly extrude. Okay, and let's call this height, extrude height. Let's call this thickness. Should do a better job on naming. I'm not very good at it. So I want to extrude it 2 centimeters, 20 centimeters out back. These are really thick walls. It's a really big building. All of these I turned on, Like this time I gave them a name, so side extrude front, side extrude front, side extrude back, side extrude side. Wow, good job, Tim. All right, then I'm going to create a group. I'm going to call this side wall. Side walls. Run it. Okay, we have our side walls as well. Let's put a null here and bring it all the way here, I suppose. And make sure we do our cleanup as well. I created all those groups for a reason. I believe I used them at the bottom, so I'm gonna keep them. We'll do the cleanup again later. All we need now here is basically this guy, right? Side walls. Out. Side walls. All right. Okay. Again, network box because they're pretty. We're gonna color them as well. I don't need this here. All right. The next thing is our inner walls. How do we make an inner wall? So obviously we're gonna need the floors again. Just waiting for it to cook on my other scene. And come on, 42. All right. So we know that we need to create floors that are equal of this, that every one of these. We don't need to create floors. These are garages. Okay. We're gonna create another for each floor. And again, primitive. So we're gonna extract one floor. And this is gonna go all the way down, most likely. Okay. We do the same thing. This time, actually, we don't. We are Windows. Okay. Is this part clean yet? No. Let's put a divide just to make sure it's clean. I didn't do it in the previous one, but I think it's better if we do it. Okay. Let's zoom in. Oh, actually, I think we don't need it in this one because we're going to extrude it regardless. Yeah, we need to turn this off and say, let's do breaker. Oh, actually, before you do breaker on geometry, make sure put it on manual, because if your scene is too big, then it's going to be a bigger problem. So let's go breaker 10 and cook it. So it's 10 meter by 10 meter divided, as you can see. That's a suspicious thing there. I'm not entirely sure what that is. Oh, laser. It connected them. So now I want to do something like this. I want to capture the outer layer as an edge group. To do that, I can drop down the group swap, and I can say run on edges, name it as outer, and include by edges. Edge angle uses edge angle and unshared. So if I go like this, it should give me the edge group, but it sometimes doesn't highlight. There's 5 of them. 510. Let's try again. Update my selection. No, base group. Okay, sorry, my bad. All right, so it kind of gave me all the edges that doesn't have a connection to the other side in layman terms, right? Then I'm grouping all the edges as well. So I'm going to do some subtraction work, I believe. I'll call this all edges. Okay. It's running on edges. So this is like grouping all the edges. So this is, let's call this borders, border edges, all edges. Again, I am defining my extrusion vector. Now I'm doing a group combine. And I'm saying all edges equals but outer edges. Okay, so if I select, it now kind of gives me all the edges but the outside edges. So I have these little square boxes. And now they're all 10 meter by 10 meter. And now guess what I can do? I can say, I wonder if we should have done a clean swap. I think because in my example I don't have that gaps, and here I feel like I should, but I don't want that. That's not very nice. Also, I see these points which I didn't have in my scene. There could be the version differences. I think I was in early 18.5 versions when I started this, so I have no idea, but we can, any free floating points can be cleaned up by a clean swap. So far that hasn't changed. I'm suspecting these areas could be a problem, so let's experiment with a clean swap again, divide, to remove those guys, and it looks like this now. But if you look at the but I do want to preserve those guys as well. Anyway, let's extrude. Let me, okay, so this one is experimental. Not this one is experimental testing. So we're gonna toggle this on and off. But let's continue now. So I want to extrude my walls, obviously, finally. And I want to run this only on all edges. Right, and I want to run this on point normal, and I'll copy this. Oops. Expression. Again, this is. Oh, okay. See, some are going up. This is not good. That's weird because we should have fed in the extruder. Okay, so change this to attribute, and then feed in that value, the extruder that we created. Okay, not -5. This is using now the floor height value. Anyway, so once this is, the building is complete, we're gonna do another pass to shift things around to make sure that the intersections are as minimum as possible or non-existent in order to be able to simulate later on properly. Let's focus on creating the building for now, and then we'll do our pass. So now let's create a blast. In the poly extrude, it's giving me a warning. It says bad parameter, but it returns me a value, so I'm not sure. I'll keep it as it is. When we do the poly extrude, create this group extrude side because we want to isolate that down. And now select your blast node, extrude side, and delete non-selected. And now we only have the rooms. Well, we don't have doors now. No one can move. So integrate the doors. There's a little problematic area here. It's coming from Let's see if the this fixes any of those. It kind of does, but we get these additional separators. I think it's okay. Let's leave it for now. Now what I need to do is I need to bring in my thick floors in case I have, this is actually one of the, I think, collision passes that I was doing. So select the loop begin, create meta import, change it to fetch input, and bring in your extruded floor, which is this. And let's do an object merge. And let's call this in floors. Maybe we'll use it more than once, so I'll give it a number. So when I duplicate it, it gets a predictable number later on. Let's do a boolean now. We can do something like this. If there's any overlapping, that's going to be taken care of here, which there is here too, I think, on one side. Let's left side is surface. We don't have thickness yet, so we're gonna say left side is surface, right side is solid, and subtract A from B. Nope, it didn't. Oh, because we need to run the. Yeah, to see the change, you need to run this. So what we can do is. Let me see. I would like to run this on a single pass. Okay, let's run it. Let's hook it up. It's not changing anything. I think I broke my session. Wait, why? You got this one for each primitive, no? This has primitives. 56 primitives, so there should be 56 loops. How interesting. Let me try this. Okay. It's not getting it. Okay, let me pause and reopen my Houdini because this doesn't make much sense. I have only primitives here. I am for each looping using the primitives only. So the expected behavior is when I click on this, I need to see one. And here I don't, because it exploded. Am I merging it? No. Even if I bypass? No. Well, let me try this without doing it. So let's keep it this way. Let's do it here. This one needs to be in, it needs to have fetch input, because here, let's copy paste this, sometimes happens, I guess. You go here, and you go here, and this is still in because you go here. Let me now do something like this. This is what I should be seeing. Here, this is not what I'm seeing. I guess sometimes things break. And this is still working? Yes, okay, let's just get rid of this. Even Houdini bugs out sometimes, I guess. And I don't even want to say bugs out because I may be doing something wrong by design, but it just doesn't look that way. Alright, so we are here. We bring in our floors. Not yet. Floors. Oh, I think booleaned it and then it showed me the result. It was actually not baking it up to date. Doesn't matter. So we're gonna do a little cleanup on this section here. It should remove some of this. It's also coming out from the bottom, so we kind of need to do that a bit better, I think. So let's do that now, as a matter of fact. Is it that we are extruding downwards, right? Okay, so let's, oh, it was maybe the 99 percentile thing. Let's go 95 percentile. This, wait. Why isn't it changing? You know what? Let's do the, let's fetch the value, which is already 5 anyway, which we used here, right? Looks like I did the same thing, referencing in several different places. So let's just use this guy, which is going to give us this. Okay, now anything left under? No. Let's cut on both sides. Okay. Best way to visualize these things is usually using side views. So this looks pretty clean to me. Again, the goal is just to make sure that it's clean, to be honest. Okay, so the next thing is to open up some doors. Basically, I want to loop through again each one of these faces inside the loop, however. So for each, again, primitive, plug it in. So it will give me one from all of these. So we are processing on the one floor now, so it's only going to show one floor. I don't need the template anymore. I want to scatter one point only. Okay. And it doesn't matter, it's using the position. And I want to copy a box to it. So this could be obviously a bit more sophisticated, but a box will do for now. My box size is 1.5 meters, 20 meters, 1.5 meters, just to make sure it goes through the floors. And I'm just going to copy it. It's a fairly simple solution. Copy the point, left input primitive, right input point. So I have a point and I have a wall, right? So just need to do another boolean. And left is surface, right is an object, subtract, and we have a door. Well, somehow a door. And then we have some doors people can walk through. Some has more than one. No, actually, because that probably doesn't have. Yeah, it already had a natural door because maybe it's next to a column or something. Anyway, the only thing that I don't have in this scenes is that I don't have like a elevator shaft area that people can come in and walk through. But I'm fairly sure it's a simple solution. You could probably pass an entire huge beam through the building, or 2 or 3, and then just keep those areas clear to give the impression that this is like a common area. Let's give some thickness to our walls now. Poly extrude, and let's call it I think this one is like 14. I gave it, I don't know why. Output back. So we have some thickness in our volumes because all of this is going to get fractured. Now what I'm doing is I'm going to create some lights. I didn't use in my renders, but if you want, you can. So what I need is my floor geo, right? Okay. Now I want to do something like this. I want to create a point at their center. So you can do something like this. Run these in primitives. And you can say add point on myself at position, right? Because it's a primitive. Then, so this already adds the point. It just adds point in the center of the primitives. Okay. But I don't want the primitives. Like, I want to keep the points. So then say remove prim. Remove prim myself at prim number, but keep the points. Okay, so we have some points. I didn't do it in the last one, but I think I'm going to do it now. I want to get rid of these points that are in the open space. And I think I just thought about it because in my previous one I don't do it. Let me show you what I mean by that so we can visualize it a bit better. So I want these lights to be, this is a bit thick light, 10 centimeters thick. Let's make it 5 centimeters fluorescent. These are all boxes. If you want to model, put your light apertures, you can, obviously. So I have some lights here. Now let's put this guy here. And I kind of want to offset them slightly lower, right? Because I want them to be not intersecting with the wall. So then I can do something like that. I can have a look here. No, where's my ceiling geo? My ceiling geo is here, right? So I want to probably move it gently down. Could be like that. Should be okay. Okay, so it's kind of like not floating either. It could be floating. It's just a light, but you can play with it. Light offset. Now, like I said, I don't want lights here outside. I just want to have lights if the area is completely closed. So I have that information. All right, so I don't want this, but I want this. I don't want this. Maybe I want this. A little cleanup. Especially like that. Then we can do something like this. Obviously, we can do, we had the extrusion, but not this one. So we can do another extrusion. Using this one, we can say output back. No. Let's do another one. Let's do a new one. Extrude, poly extrude. And I want this to go down as much as I said here. Okay, and I want to make sure it's closed. Now I want to find what's outside, and I want to get rid of it. Oh, we could do the negative, sorry. Okay, so in this scenario, 1 or 1.5 or 2. Let's see how it goes. Then we can say group the points. Temp out. Group the points using bounding regions of an object and blast everything that is not inside this bounding space, which is temp out, delete. So it kind of removed 2, 3 of them, and we do want that anyway. Wait a second, let's go here. Oh, that's not what it did. It removed everything. Let's see why. Maybe we need to do a little offset. I don't think so. These points are already inside. Oh, they're right on the walls. Sorry, we had to do the grouping after the moving. Or we need to offset them here. Let's do that. Okay. So we're capturing 3 free floating lights, so we're getting rid of them. So these are my lights. Let's create a group. And then basically you can say, you know, when you render, some are off, some are on, some has different colors to make a nicer variety. Okay, so let's go here. Before we export, right, we're gonna export this soon. We're gonna do a cleanup, export it. Let's call this maybe another random box here, say office lights. Office lights. Now I think we can merge these at this point. Just make sure that I have the groups I need. So these are my walls. I don't have walls here. Let's create the groups and the materials as well. So let me copy one of those from here. So this one is ID, I guess, inner wall. Different texture for inner walls. ID inner walls. I can do the same thing for this guys. This one is ID lights. ID lights here, up here too. Now let's fix the groups. Actually, we can probably do that outside as well. Pretty much this. Then this goes up here. We need to, I think, preserve some space here, or maybe move this thing a bit up. Doesn't break our border. Okay, let's do like this. Okay, now let's run it. I'm gonna kill it. I'm gonna save it. So obviously it's going to take a bit more time now. But our building is coming together, and all we need to do is to change a single value to get a completely different, well, not completely, but a very different look. And instead of, we can also do things like, while this is calculating, we can also do things like, instead of feeding in one shape at the beginning like I did, we can add 2 shapes, you know, like the Petronas towers. So there's 2 of them. That will kind of make it look a bit more interesting. Okay, so we have our now rooms and lights. I think that's all there is here, and I'm gonna say null. Probably just separate these with a plus from lights. Oh yeah, office lights and not office lights. So here I'll say office lights are gone, right? Yes. So these are inner walls. Duplicate this, say everything else, out office lights. Okay, let's bring this down, this is getting taller. So we have now, I'm gonna finish the video because we need to split it. So next thing is left is the columns, antennas, some outer wall processing, and then we'll kind of bring them all in to make sure that they're all in good shape. Create unique attributes for connectivity pieces, just kind of maybe do override of what we have been doing here to make it a bit more clean if we skip the step. Once we have the building generation kind of working, then we're going to go back and start to make sure that intersections are fixed. And that's pretty much it. So let's have a look at the final look as it is now. I'm just gonna object merge everything. This is the slowest method, but why not? I have this guy as well, and I have the floors as well. Let's just save it. Turn on the flag. All right, our building is coming together, as you guys can see. All right, it's happening. And then later, you know, it's like fracture and let it collapse. Super cool. All right, thank you for watching this chapter again. You may have noticed I'm trying to talk a lot clean. I realize that I am maybe sometimes when I listen myself back, I hear that I'm connecting the words. My native language is not English, and there were some complaints on some websites where tutorials are shared. So I'll be more careful now, so you guys can understand me much better. But also, please, this is not a linguistics tutorial, obviously. So let's pay attention to what matters, which is Houdini here. And thank you for watching.